So good evening to all of you and good morning, Ayomide. Okay. Are you guys able to see my screen?
Yes, sir.
Okay. Let's move forward. Now let me ask a fundamental question to all of you. Is Spark fast or slow?
Fast.
Fast. Just because you saw Tita, you think it is fast, is it? Priya?
No, I like
She says it is fast. Is it true? Mahesh, is it true?
Spark performance depends on the situation, like what are the systems that are connected and how fast they are, and also what is the network speed, as well as how many RAM or the processors are involved. All those will matter, and how many parallel processing is being done. Those will be the factors which determine whether it is fast or slow.
Okay. So what you are saying is absolutely right. All those infrastructure, hardwares, everything is same, and we are using Spark. Okay, that is the thing. Then we are using Hive. Then we are using MapReduce directly. Which one is first now?
And now I think Spark will be faster.
Considering all other parameters are same,
yeah,
then Spark definitely beats over Hive and MapReduce. There is no doubt about it, right? The Spark came into existence because of the shortcomings of the MapReduce, right? So obviously they should be doing something as compared to Hive and MapReduce. They should be doing something different. We understood definitely Spark is a cheetah. Of course, it has a patience like a turtle when you want to use it as a turtle, but it is fast. It is fast as compared to the Hive and MapReduce. Okay, and why is it fast? Mamata, why is it fast?
Sir, it runs in memory.
Okay, it runs in memory processing. So now that we understood Spark is fast, there are many factors contributing to the fastness of Spark. One of the factor is how it optimizes, how the whole Apache Spark execution happens. That is one of the factors. Okay, within that there are different layers, like one of the, as we already discussed, in-memory processing. And apart from that in-memory processing, the way Spark has structured, sequence the execution in a most optimized way is a major factor contributing to the fastness of the Spark. Okay, as we already understood, bare minimum 25 times faster than any other tools like MapReduce. Okay, within Spark, we have a component called Spark SQL. I mean, that is the reason when you Spark code, we'll say imports from PySpark.sql, because more or less most of the functions are included as a part of PySpark.sql. Okay, so this has core of the Spark has a catalyst optimizer. Okay, and apart from the catalyst, it has a Tungsten. Okay, both of them are engines. Have you heard of a Tungsten at any point of time, Bashir? Tungsten? No? Are you sure? Mamata, have you heard of a Tungsten?
No.
How about others?
he invented some
Like it will like faster the reaction. Like it will help to faster the reaction. Like I think it I've studied it in chemistry somewhere.
My memory goes back to my childhood days. I remember, if I correctly, we have a bulb. I think within a bulb, I think I hope you guys are, I don't know whether you guys have seen that in a, okay, that filament, what are used to happen, what are used to be there in the bulb, that used to be tungsten filament, right, Mahesh? Do you think?
Yes.
Okay,
yes,
that used to be tungsten filament.
Yeah, correct.
Do you guys remember, any one of you?
Yeah, I remember.
You remember? Okay, so Priya remembers. Anyone else? Mamata, do you remember in your childhood days? I don't think any bulbs will come out with the tungsten filament these days. I don't know which, maybe it is there. At least I'm not. We are not sure. We are not observing the bulbs. I think more or less all the bulbs are either CFL or this tube lights, which
LED
has LED bulbs. LED. I don't think LED bulbs has a Tungsten
It
filament.
won't have, it won't have filament.
Okay, wonderful. Coming back here, Spark uses engine called Catalyst and Tungsten to optimize and run the queries. Okay. What is the version of the Spark as of now? Ayomide, what is the version of the Spark currently which you are using?
I want to say 3.4. I'm not sure.
It is 3.4. You are right.
Oh,
3.4.
okay.
Okay. So now the powerful Spark is having a 3.4 version. Obviously, 3.4 version didn't happen overnight, right? So Spark is in the development right from 2009 as a part of the which university? Anyone?
Berkeley.
Yeah, Berkeley. Okay, University of Berkeley. Okay. Okay, it is almost more than 12 years now. So from there, in Spark 1.0, they introduced the Catalyst Optimizer and Tungsten Execution Engine. Okay. Then in Spark 2.0, they added the cost-based optimization. We'll look at that. And in Spark 3.0, they included adaptive query execution, which is also called as AQE. AQE, adaptive query execution. Fair enough? Any questions? Anyone here? Does anyone have any questions? If you don't have a question, please confirm me. There are no questions.
No, Mahantha. No.
No questions. Okay. So what are we talking here? What are we talking about? Mahantha, what are we talking here?
There is structured API execution.
Yes. Mubashir, are you following me? Are you able to follow me?
Yes, sir.
You are following
Yes,
me, right?
yes, sir.
Why
Yes,
are you
yes.
following me? You should be following any girl. Why are you following me? Huh? Mubashir, why are you following me?
Since he's in front of the system.
Okay, I was kidding, Mubashir. I hope you get my poor jokes now, Mubashir. Are you getting my jokes? Okay, for that he's not responding. I think looks like my jokes are understood mostly by Mahesh, next by Priya. Then Ayomide also struggles to understand my jokes, right? Ayomide, are you following my jokes these days? Are you getting my jokes? I mean, I know they are poor jokes, but are you getting at least that they are poor jokes?
Yeah.
Okay. I put Ayomide in a position she has to say yes. You can choose to say no. If you're not getting, you can choose to say no, Ayomide. Okay, I don't mind. Okay, coming back. What is optimizer? I mean, we are talking about a catalyst optimizer, tungsten optimizer. What is optimizer, by the way, Mahantha?
How fast?
So optimizer is in a way at a high level which optimizes the execution of something. Okay, here in this case, optimizer is a rule executor of the logical plan. What is logical plan? What is rule executor? We'll come to know that in a couple of slides. So what is catalyst optimizer? Is also a generic logical query plan optimizer. What is generic logical query? We'll understand in a minute. Okay, so in a way, it is the core. It is the core of a Spark engine to optimize the plan, which saves lot of resources. Okay, which saves lot of resources. And what does it do? It also works on the optimizing the physical query plan. Okay, so Catalyst Optimizer is the one of the core engine which optimizes the logical plan also, which optimizes the physical plan also. That is what is Catalyst Optimizer. How exactly the whole thing works out in the execution of the structured API? Let us understand that now. So in order to do any data analysis, what will you do, Mahesh? What will you do?
We'll have to prepare. I mean, prepare a query wherein it will not be looping it in too many ways, and we have to optimize it.
So basically, in order to do a data analysis or data engineering as a part of your project, what will you do?
We will be joining a lot of tables.
Basically, you are going to write a PySpark application.
PySpark. Okay.
PySpark code. You are going to write a PySpark code to do the analysis or do the data engineering tasks. That is the first thing. Let us say our Mahesh has written a wonderful code Okay, by using any of the structured APIs. It can be SQL, it can be data frame, it can be dataset. Mostly it is a data frame. Okay, are you with me, Priya? Are you with me, Ayomide? Mahantha, Mubashir, are
Yes.
you with me? Okay.
Yes.
Where are we
Yeah.
now? Where are we now?
Georgia.
Huh?
Georgia.
Thank you. You also started getting me. Good. Thank you. I like that. Okay. So, thank you. Okay. So, assuming that all of you would have written a wonderful code, as I said, me and I think you would have heard a dialogue between me and our Mahesh. So, we have written a Spark code on any of the structured APIs to perform some data analysis task, data engineering task. Then after writing the code, what will you do, Priya?
After writing the code, we will check whether code is right or not. After that, we will execute.
No, correct. What you are saying is makes sense. What you are saying is right. You're right. Okay, good. Then after that,
We will execute.
correct. So only one thing what you have to add is here in this case, you will submit code to the cluster where the Spark is installed. We're going to submit the code to the cluster. Okay. And after you submit the code to the cluster, either through a job or through a terminal, it passes through something called catalyst optimizer. Okay, it passes through something called catalyst. That is what we discussed. Catalyst optimizer is a core engine. This guy creates a logical plan. Which guy creates a logical plan? Catalyst optimizer. This guy creates a logical plan, and also logical plan is converted into physical plan. Okay, logical plan is converted into physical plan. This physical plan gets executed in the cluster. Everybody understood this, right? Can you quickly jot it down on a notebook, please?
Done, Mahantha.
Okay,
I'm done.
wonderful. Now we'll see what happens in the logical plan. Are you guys ready for that?
Yes.
See what happens, on a day-to-day basis, you may not need all of it, but if you understand this well, you may be able to structure your code better. Okay, and if you are planning to take a certification, this is another important thing. Okay, so by the way, whatever the course I'm teaching now, more or less I'm preparing you for a PySpark certification. Now, user code is written by all the wonderful and beautiful people like you guys, and you guys submit it to the cluster. Okay, when you submit the code, it will be in a unresolved logical plan. What does it mean, Mahesh? What does it mean? What is unresolved logical plan?
It is yet to be optimized.
Correct.
It is not yet optimized.
Rather than saying that, okay, so what happens is when you write a code, when you write a Spark code, when you try to create a data frames, whatever the kind of data types what you provide may not be the right ones. Okay, so Spark maintains something called catalog. Okay, which is a part of, we can say, catalyst engine, which has the right information about the right info about the data types and other information of data frames or what other code you are trying to write. So Spark compares this plan in terms of data types and all those things with the catalog, where it maintains its own type information. And if everything is fine, this unresolved logical plan would become a resolved logical plan. Resolved logical plan means all the data types, everything is looking fine here. Okay, so after the analysis, along with the information from catalog, unresolved logical plan would become a resolved logical plan. Remember, we are only dissecting the logical plan of the previous slide. Okay, if I go back here, see, there are two important parts here. This is the first part and this is the second part. Okay, I'm elaborating this in the next slide now. Okay, are you guys with me? Okay, so here first it will be unresolved logical plan. After analysis along with the catalog, it will become a resolved logical plan. After that, there will be a logical optimization. When I say logical optimization, at the high level, what should be the sequence? You have written some sequence. What should be the sequence? Okay, of different transformations. All those things will be taken care here. Then in the end of logical plan, we'll get a optimized logical plan. Okay, so if you look at your previous diagram where you had drawn, the logical plan is expanded into this. Okay, expanded into these steps. Output of the logical plan is, after all these steps, optimized logical plan. So output of the optimized logical plan phase becomes the input for physical plan. Okay, becomes the input for the physical plan. Okay, then what happens is Spark takes the optimized logical plan and creates different physical plans. How exactly I need to sequence them? What should I do? All those things in terms of utilization of the resources. What should be the ideal way? It develops some different physical plans. Okay, and these physical plans are subjected for cost model analysis. Okay, when I say cost model analysis, okay, plan 1 is sequencing the activities like this. How much of resources it is using, within how much time it is giving the results. Okay, at a high level, it compares the different physical plans and performs the cost model analysis of all the physical plans, and it chooses one best physical plan considering that situation or the context of the analysis. Okay, so that is what happens, right? So mostly this best physical plan will boil down to the RDDs. What are the RDDs? We'll discuss that. Okay, then that best physical plan gets executed in the cluster. Make sense? Any doubts here from anyone?
No, sir.
No doubts. Now the story is not yet done. Did we discuss about some bulb or something like that, Mahesh? Hello, Priya. Did we discuss about some bulb
In this slide or the previous slide?
in this one?
Yes,
Yes,
please.
What is there in the bulb?
Tungsten.
Did we cover the tungsten?
as part of filament we have covered.
Thank you. I like this. So now if you crack jokes like this, now mind opens up for you also, for me also. We'll get more energy. So as a part of the filament we have covered, but as a part of the Spark, have we covered the tungsten? Not yet. But any idea? Anyone? Any volunteers? Okay. Where does the tungsten fit here, and what kind of a job it may be doing? What job it is doing? Any idea? Anyone? Are you guys with me?
Yes. Yes.
Okay. So this is the whole thing. This whole thing is taken care by this guy. Now, guys take care of all this planning. Nah? Let us refer tungsten as a girl here in this case, hypothetically. Tungsten is helping us to generate the optimized code. So whatever we have learned here, that is a plan. Actual code is not still available, right? So Tungsten is responsible for generating the optimized code. Okay, it has various aspects of how it generates the optimized code by using some half like heap memory analysis, or multiple things are there. That is not really scope of this particular lecture, okay, at the moment. Okay, so this is how the whole things plays out with all these things played in an orchestra, in a nice synchronization of different instruments. Wonderful data processing is done by a Spark, which is minimum 25x more than any of the other contemporary tools. Make sense? Any questions here from anyone?
No.
Okay, wonderful.